Well, hello and welcome to this webinar today, jointly hosted by SimScale and Thornton Tomasetti. My name is Dr. Nadman Khan. I'm from the marketing team here at SimScale, and I'd like to welcome everyone to this event. We're joined today by speakers from Thornton Tomasetti, Jeroen Jansen, and from SimScale, Ricard Schuler. And today we're going to be discussing a new digital wind tunnel app in Rhino called Nuada.CFD. Let's take a quick look at the agenda. This is a new app that's been made by integrating SimScale with Rhino 3D to accelerate the building design process. Now, what's interesting is that SimScale yesterday hosted a fantastic event called Engineering a Better Planet, looking at simulation for climate technology, right? And that was looking at advances in engineering simulation, building design tools to enable decarbonization of society at large, of our buildings, cities, urban design, infrastructure. And this app, Nuada, very much fits into that ecosystem of design tools. So very excited to host this webinar today. And very quickly on the agenda, we're going to introduce SimScale and Thornton Tomasetti and explain a bit about this collaboration. We're then going to introduce the Nuada.CFD Rhino plugin, explain how that works, followed by a live demonstration. And we'll show you how to access the app in 3 simple steps. Now, we have the developers of the app speaking today, so it's a fantastic opportunity to ask some questions and answers, which we'll take at the end. Now, you all have access to the questions panel in GoToWebinar. Please use that throughout the event to post your questions, and we'll try to get through as many as possible. I'd now like to hand over to Jeroen from Thornton Tomasetti. Welcome, Jeroen.
Thank you, Nagman. Hi, everyone. Very briefly, I wanted to, for those of you who are not familiar, I wanted to introduce Thornton Tomasetti. So we're a global engineering firm. I'm based in London myself, and we engineer many things, mainly buildings, from tall to long span sports stadiums, movable structures like the Shed in New York, or special art sculpture types. For many of these projects, some of them come into the whole special geometry and that type of thing, and that's where personally I often come in. So I'm sat in what we call our core studio team. So this is our research and development innovation team. So we're involved in projects like these, but also software development, application development. And I have been looking at CFD, wind studies around the buildings quite a bit. So whether they're tall buildings or sports stadiums. And coming out of that, we've been starting to develop the Nuada.CFD app. So to really harness that high-end engineering, the CFD simulations, together with our 3D models, and actually bringing that in the early stage of the design processes. And that's what we're going to talk about today. But first, I'll leave it to Ricard to introduce SimScale a bit.
Thank you, Jeroen, for the nice introduction. So my name is Ricard Schuler. I'm here at SimScale, product manager for AC. And I wanted to quickly introduce SimScale to you. Maybe you haven't heard really about us yet before the webinar. So let's take a few moments to introduce what we're doing. So essentially, SimScale is a platform where broad physics applications for engineers and designers can be accessed. And it's really built for all users, right? For designers that are new to simulation and need design decisions early in the process, up to simulation experts. We are cloud native. That means you don't need any specific hardware to access SimScale. I can just type simscale.com in your browser and log in, and you're done. You have instant access, no remote desktop, no specific settings you need to adjust to. It's a true software as a service model that we're applying here. As we're cloud-based, that means that we can enable real-time collaboration between team members that work on a single project or that work collaboratively on multiple projects together. We have team management capabilities, administration options, and so on. So for the full engineering organization, we can organize the CAE work on SimScale. On top of that, we have live support on the platform. So in case where you have questions on your simulation setup, results, whatever it might be, you can instantly access our live support. And if you wish, you can either share directly your project with our support, and it can instantly see, as you see, your project and recommend changing any settings in the project. Think of it like Google Docs for engineering simulation. And as well, what's enabled through the cloud native nature of SimScale is that you can simulate in any scale. You can run simulations on very small models, parts, buildings, or up to full cities with hundreds of millions of cells for a CFD. Not only that, but you can run also multiple design options or parameter studies in parallel, right? So you can run hundreds of simulations at the same time, which wouldn't be possible on any local hardware. And finally, still, SimScale is a cost-effective solution. So there's no large upfront cost to get started. You can scale depending on your demand and on your usage, starting from a single user model up to models that enable usage of hundreds of users. So that's SimScale in a nutshell. Now quickly on the applications that we empower for AEC, architecture, engineering, construction, just a subset for visualization. In the top center, you see one of the most successful applications on SimScale to date, which is the pedestrian wind comfort analysis. So on urban scale, we enable CFD studies of buildings and how they impact the pedestrian level winds, and in a very automated and user-friendly way. But we can also look into the building itself. For example, on the top left, we see a large theater, so we can assess the thermal comfort of the occupants, the HVAC requirements, humidity, temperature distribution, stratification effects, and so on. We can also run similar studies on data centers, facade analysis, or coupled analysis that impact outside and inside of the building together. For example, on the top right, we see a study where we assess the natural ventilation capacity of a building, taking into account the surroundings and how that might affect the pressure on the facade and how much natural ventilation strategies can work on a specific building design. So as we can see, SimScale has really a very broad range of applications, not only in AEC, but across all industries, starting with structural analysis, thermal analysis, CFD, and coupled analysis as well. And SimScale is built basically on a foundation infrastructure with multiple solver technologies that we employ. That's open source based tools as well as commercial solvers that we employ. And this is all connected together through the SimScale API and brought to the user, typically via the SimScale workbench. One opportunity that we saw is still one of the last barriers is that often users that don't have a very high or regular demand in complex simulations, like for example architects, there's still some barrier to leave your analysis or design workflow that you're used to, for example, from time to time do CFD. So for these people, we wanted to generate a solution that integrates in their existing workflow into the actual design tools that they're using and directly get value where they are most of the time in the daily work. So in this sense, we could, with the SimScale API, have simulation experts that actually design these workflows, and then they distribute it through this design tool, through the design tools to the actual architects and designers, right? And this enables a lot of new possibilities, new workflows, capture know-how into the company instead of giving it away to third parties and consultants. It also enables new service models or new services, like what we have seen, or what we're seeing today together with Thornton Tomasetti and the Nuada.CFD app. So these are just 3 other examples on how new solutions are built on top of SimScale using the SimScale API. We see on the left side a demonstrator that we built together with Esri, an integration to ArcGIS Online, where we have basically the CFD data from SimScale geolocated and delivered via ArcGIS Online for policymakers, decision makers to review directly into the GIS solution CFD results. In the middle, we see an integration or a plugin of NVIDIA Omniverse, where you can directly from Omniverse export your scenes to SimScale, run the CFD analysis, and most importantly, get the results back into Omniverse in a seamless way to combine it with other results and visualize it and generate nice animations, for example. And the typical, on the right side, the typical Grasshopper plugin integrations, also powered by the API, where it can do any kind of imaginable study, combining powerful tools that are existing within Grasshopper with SimScale. So enough of that. Now let's get to the meat of today's presentation, to the actual Nuada.CFD app. And maybe, Jerome, you can start showing us what it can do and what this is about.
Yeah, absolutely. Thank you for that introduction. So yeah, it's really that opening up that API to customers, to ourselves, let's say, and wanting to look into more of these streamlined workflows so that you are fully into the Rhino development and into the Rhino environment, and you don't actually have to leave that. So we decided to develop this app, this digital wind tunnel app that specifically looks at pedestrian wind comfort, or which directly takes into account multiple directions, so 16 or 8 or whichever you like, or single direction studies where maybe you look more into wind loading and facade pressures, that type of thing. It uses the SimScale platform in the backend. So within Rhino, you set up your simulation, it sends it to SimScale in the background, runs it through their LBM, the Lattice Boltzmann method, Pacefish, and then gets the results back into the Rhino environment. We looked at a new, and we get to that at the end, at a new licensing, a new pay-as-you-go licensing model. So you pay for the GPU core hours you run it for. And just to summarize, like Nuada really is geared towards building scale simulations, so pedestrian wind comfort, and really trying to bring that to the early design stage. So when you're doing a competition or the very early stages of concept design, try different options, try different massing studies, and therefore building aerodynamics and wind studies on the ground, but also rooftops, terraces, and any private balconies. And then look at mitigation or improvement of the situation. Can we do that with trees, vegetation, screens, etc.? So let's go on to the next slide, which is a live demo. So we basically set up a case, and we'll show you through it now how easy and quick it actually is to get it set up. So we got this model for central London. So this is City of Westminster. So you see in the bottom the House of Parliaments, Westminster Abbey, part of the river. We're going to look at a dark green building in the, I think it's the Royal Post, in the center. We got two options, so we're really excited now. We've implemented a new feature that actually allows you to look at different options, running them within one project, and then in the results, you can actually evaluate these different options together as well. So we're launching the Nuada app here on the right-hand side. So this is fully embedded within Rhino. So you type Nuada, brings you to that screen with all of your projects. We clicked on the plus button at the top. So the app then creates a new project, asks you a little bit of information like a project name, number, little description, and location where it is. And then a few of those screens, like just 5 or 6 of them, allows you to set up the simulation. So how it works is it's divided in a set of groups. So this first one is the building of interest. So that's a dark green building we're looking at. The next group of layers. So all this selects the layers in Rhino, basically. So if you're familiar with Rhino, this comes pretty intuitive. So we're selecting the context buildings at this point, all of the ground surfaces. And then at the bottom, that's a new feature just now, you can add additional scenarios. So in this case, we can name that option A. And when you click select layers, we go down and select option A here, add a new scenario. So we're now running a base case plus 2 scenarios, option A and option B, which is, you just saw it a minute before, we extended that front, that tip of the building to a tower in 2 different shapes. And then, so we're working on the preview, so I'm hiding the geometry now. This is now preview from the app. So the app shows you what are the buildings and geometry that we've got included within your study. We're choosing a pedestrian wind comfort study, pick up the climate file. So the climate file is your typically measured on an airport, your 30 years of measured data, the windrows, which it uses for the pedestrian comfort. Few more settings like the terrain, which you can set for all the directions at once or individually. If you, let's say you have a coastal area, something where it's quite different. And then the way the SimScale solver works is that you have to select, before you run the simulation, you have to select which surfaces and areas you want results for. In this case here, we're selecting the ground and the terrain as the surfaces where we want results from. And you can define a radius of interest around your building. A couple of more default results like vertical and horizontal slices. We're just going with the default here now. And that's it. Then we press finish and review. You get a little summary of all of the options you've tested, and you hit run and start. So what it does now, it's preparing it on your first local machine, but then it pushes it up to the cloud. And you get a prompt when this bar is full. You basically get a prompt. Okay, this is going to run this specific case around 45 minutes, 10 GPU hours. And at that point, you can say, okay, and this is the moment that starts the simulation on the platform, and you kind of get charged. Actually, maybe one interesting thing before we go on is to notice that, so you see setting up a simulation just literally takes 2 or 3 minutes. I didn't do anything on this model, right? So this is one of those very messy 3D urban models that you get in. You see the mesh. I did not clean up anything. The only thing I did is extend the ground. So because there's a little elevation change, you do need to extend your ground so that it's larger than your digital wind tunnel. But other than that, and these options, of course, other than that, I did not clean anything on this geometry. So that's really the robustness of the LBM solver. Like you basically save, like, I don't know, 3-4 days of cleaning up geometry compared to the more traditional solvers. So that's setting up and running the simulation. Once that's done, we can then, in this next recording, go back in, click on one of these projectiles. So once it's done, you go into the project, choose your run, and in this case, the statistical solution field. So that's the pedestrian comfort results. And so it prompts you to download it first with that first button of the 3. You choose your comfort you want to visualize, in this case, the loss in LVDC, and you can hit that little eye in the middle to actually visualize it in your browser. So again, we're still in Rhino. We haven't actually left Rhino. So you spin around Rhino, it's your controls you're used to, and you now have this color plot. So you see that I forgot to turn the roads on when I was setting up the case. So therefore, we don't actually have results on the roads, unfortunately. That was the base case. We now go to option A, also the statistical surfaces. And you actually see that you can then, in this case, we're talking about central London, so there's not that much of a difference. Should have taken a more extreme case probably to show that. But you can actually quickly flip between them, set up your whatever, your cameras in Rhino, and actually get similar viewpoints, take some screenshots and that sort of thing for reports or whatever. and really look at those results in your familiar environment. Option B, similar story. We go to the statistical surfaces, the pedestrian comfort, download it and visualize it, and that's it. So this really, gives you an end-to-end workflow from your models when you're used to be working in Rhino, setting them up, creating the geometry, creating these 2 or 3 options if you like. There can be as many as you want. And then really in like 2-3 minutes, you got your simulation running. Once that's done, 45 minutes, an hour later, so this was a medium resolution, you download the results and you actually just visualize it like this. I've been showing, and I think that's what we're going to see now. I've been showing that solid 2 input. So that's actually the simulation results, the geometry we're downloading off the SimScale platform. But if you actually have set up your own rendered styles, you could also choose for that, right? So you could actually turn the solid 2 input off. And I think that's what I'm going to do now. Yeah, turn it off. So it only loads the comfort planes, and then in the layers in Rhino, you could actually show. You just don't see it on the command bar at the moment. But now we're back in Rhino, and I got some specific visual settings set up where you can actually play with that. So mine is rendered, no lighting. So you can actually play with. You can even have it on a rendered building and your comfort. As I said, we're in Rhino, so whatever is possible in Rhino, you can actually do. And that's a very, very quick round trip of pedestrian comfort. Similarly, so we showed only the statistical surface as a result, but similarly, you can also run individual directions. Look at vertical cuts through the domain or pressure distributions on the facade, let's say, and compare those together. And I think that's it for, that's it for the live demo. Let's move on to the next slide. Because I guess the next question really is like, okay, that's all great, but what am I looking at in terms of time, in terms of GPU hours, in terms of cost, right? So we're really trying to go for the early design stage. And in the app, you have the option to do a low resolution, medium resolution, a high resolution. So the high resolution, that's your full scale end of stage simulation. So the high end ones. But if you are working in a competition phase or the early stage, you might want to choose the coarse or the medium resolution. And we've got a few options here. So the low resolution on the right hand side, that just takes actually 20 minutes, 1.5 GPU hour. Even just for 16 directions, super quick. And again, as I said, you're not cleaning actually up any geometry, so that time you save as well. And the 2 ones on the left are either a pedestrian comfort again, medium resolution, or facade pressures with 1 or 2 directions. I think this was 2 directions. They're both run for about 45 minutes. And the pedestrian comfort is in the range of 4 to 5 GPU hours, and the 2 directions were 1.5 GPU. So they're actually all pretty reasonable in time and cost. And then the next question is, how do you actually get access and install it? I'd like to hand over to Richard again to talk a bit about that.
Great. Thanks, Ron. Great presentation of the app. I really am excited that we now have the feature to actually use it efficiently in the earlier stages when you want to run multiple design options in one go. I think this really adds a lot of value, where you have comparable setups through all your multiple options and can just run it off the bat without any thinking about, okay, how do I prepare the geometry? How much do I need to clean up? How much time will it cost me? I don't know. Can I commit that I will get the results finished until Monday when I need to hand it in, and so on. So that's really nice to see. Yeah, so the question remains how to get access to it. And it's actually very simple. we have a landing page on simscale.com/product integrations Nuada.CFD, where you have to basically request access to the app. You push the button and sends an email to us, and then you log in. But don't forget, if you do not have yet a SimScale account, you first have to set up a SimScale account that we can associate your usage to. Right, so you agree to the user end-user license agreement, and then you can log into SimScale after you activated your account. The next step would be you need an API key. The API keys are now self-managed, so you go to your profile, give some description, and then generate the key. So this will be the only time where you basically have access to this specific key. So just copy it from here and then use it later to activate the app. But don't worry, at any time you can remove existing keys, generate new keys, disable keys, and so on. But yeah, you only see, or you never see the key, but you can copy it here from the interface in a safe way, and then you go to Rhino after that and install the app if you haven't yet. So you go normally to your package manager, type in Nuada.CFD, and then you'll find it. Meanwhile, there's a new version available, but it's exactly the same process. You install it as any other plugin in Rhino, and then you do a quick restart to ensure it's properly activated, and you're good to go. You type in the command line Nuada.CFD, and it should open it within a second. The actual panel, you can dock it, and then on the first login, you basically have to input the API key, and there you go. If you already have some projects on SimScale with that account, it'll show you the projects here. If not, use the plus button to generate a new project. One thing you need to take into account is that you first need to activate your user to be actually able to use the API in the way that is required with the app, and that can take up to 24 hours. So that's about it. This is the way where you basically can request access. After this 24 hours maximum, you get at least like 5 GPRs to start with exploring the app. And from then on, you basically have a packaged approach. So you start with a starter package of 500 euros. With that, you can get 20 additional GPRs plus the 5 you already get for free for signing up. And then you can, for each single GPRs, pay 25 euros, or you can get them in bulk packages, which obviously reduces the price per GPR. And as we've seen, right, so the simulations that we've seen before are between, let's say, 2 to 5, 6, 7 GPRs that might vary a bit based on the location. But as we've seen, you get an estimation of your cost for a specific setup before you actually start your simulation. Yeah, and small disclaimer, we have just discussed about it. There's still new features coming regularly, so the app is still under active development. We're trying to catch up basically with the functionality that we already have on SimScale, the core functionality with the Pedestrian Comfort app, and focusing here actually really on the early stage use, where we might not go to the most complex setup or requirements, but we really want to ensure we get results, we get them fast, we don't have to worry about cleanup or anything else, and we have a robust workflow to get our answers early in the design process. That's why we want to basically build for you to use the app. And with that, I guess we're about on time to start with the Q&A.
Yeah, thank you. And maybe actually to follow up on your last comment, it is very much on the development, and therefore we're also very much asking for feedback. Like, let us know whatever you think, what works well, what doesn't, what you'd like to be improved or missing features. We're very much open to suggestions and comments.
Brilliant. Thanks so much, Jeroen and Ricard. We do have some questions coming in, so let's get stuck into those.
Right?
I guess the first one, Ricard, maybe we take a step back. So there might be people watching this who aren't familiar with cloud computing as we know it, right? So one of the attenders is asking is, what is a GPU hour? If you could just explain that and how does that really work in the context of this app, please?
Yeah, that's a good question. And sorry, I brushed over it because we're so used to it at SimScale, meanwhile, that we don't really think about it, but that's a very good question. So to take a step back, the Lattice Boltzmann solver runs on GPUs, right? So graphical processing units, because they're very efficient in computing massive amounts of data in CFD with this LVM solver. So these graphical processing units are not ours, right? We're renting them as a cloud service from Amazon, right? So basically, if you run a simulation, it takes 1 hour on one GPU. It basically costs you 1 GPU hour. We are having different sized machines from 1 up to 16 GPUs, I think. So if you run a case that uses a 16 GPU machine for 1 hour, it's basically 16 GPUs. But it's up for like 200 or 300 million cell simulations. Yeah, and that's basically how the pay-as-you-go model works. If you run larger models, if you run more models, you will be using more GPU hours, and you have to basically pay more. But the good thing is you pay for the value you get.
Okay, brilliant. You mentioned Lattice Boltzmann solver a couple of times there, Ricard, and it related to another question from an attendee about how accurate are these results? Because Jerome, you mentioned this is suitable for early stage design, and you might have non-CFD experts using this, right, to come to some design decisions, even though it's early stage, but they are, in fact, design decisions, right, which impact the project. So how can the architects and early stage designers have confidence in the results?
So from here, for sure.
I can try. I can give that a start,
Yeah,
and
go
then
for it.
maybe you can fill it in. No, it's a really good question, actually, and that's where I think different types of simulations and precision come in at different stages of a project. So the Lattice Boltzmann solver, without going into too much detail, is a different type of solver than most of the traditional CFD solvers. So traditional CFD solvers are what's called often finite element or finite volume solvers. They run on a CPU on your regular processing unit in your laptop, or could be on the cloud as well. The Lattice Boltzmann solver, it's a different mathematical engine, and it also runs on these graphical processing units, as Ricard was saying. Because of the graphical processing units, it runs in parallel and it runs lightning fast. So the nice thing is these are actually transient simulations. So it actually varies over time, right? So you can actually see the wind go around the building, and the buildings in itself will generate some turbulence. And then there's two types of looking at these things: transient way or time averaged. The pedestrian comfort studies, they take that time averaged and then look at that over a full year. So they compare those 16 results, if you run it in 16 directions, with the windrows. And then the resolution where that comes into play is that your quick and more low resolution workflows are cheap. They are quick to run. They run in like half an hour or so, real time. They then, it's more of a qualitative comparison, like is this massing working better than the other? If I chop off a corner, if I make it more aerodynamically streamlined, is this performing better? That level of decision. And then you can go up to the high level where it actually, the precision is much better, and you'll get much better into actual values. And that's also the level where maybe you actually start to look at loading, wind loading and stuff in the actual values of pascals on kilopascals on a facade, let's say, which I wouldn't really advise for those low resolution But then also there's a cost difference, right? So the early stage, that's maybe your 50 euros or something like that simulation. The high end, you're probably looking at a couple of €100 or maybe even 1,000 or more. And probably they have a different location in the project. Maybe that's where you, I don't know, ask for more fee, right?
Brilliant. Ricard, anything to add to that? Maybe about some validation that's
yeah, exactly. So that's one way to look at it. Obviously, you have the choice to go coarser or finer. That impacts on the accuracy versus effort and cost. But that's true for most of the solvers out there as well, right? So what we have also done, obviously, on the side is validating this against wind tunnel experiments and traditional CFD solutions that we also have on SimScale available, right? We have other solvers as well that we compare this to. And the accuracy is the same or higher than with other solvers. It can be higher because we are resolving more of the physics than traditionally you do, because traditionally you cannot afford to run transient simulations with a finite volume solver typically. On the other hand, the Lattice Boltzmann solver can also be used to scale your resolution as you want it, right? So typically what you have to do is if you want a very low resolution result, you need to ensure your CAD is also compatible with that. Otherwise, you cannot mesh the geometry like this, right? So you have to remove small parts, small fillets, small corners that you otherwise cannot resolve with finite volume, right? So in that sense, you have a bit more flexibility to typically have, because you just decide on the solver what you want to do.
Brilliant. We'll take a few more technical questions, Ricard and Jerome, and then there's a couple of questions about the pricing and commercial side. We can come back to that at the end. Yep. So just sticking to the technical topics, we have a couple of users asking us about, is this tool appropriate to model wind mitigation measures such as wind screens, canopies, trees, vegetation, and so those smaller features, are they suitable to model here? And also the output of the results, for example, the comfort map, is that available only on the ground level, or can it be on any surface?
Right, to start with the last one, it can be on any surface. So it basically works by layer, right? So it's the layer table in Rhino. So in the first screen in the app where you set up your case, you select the layers that you include, and within that you can select the results. I think in the example I only show the ground, but you can actually take ground and roof terraces and balconies very easily as well.
Yep.
And then you have an offset, so you can take the typical like 1.5 meter above that, which is usually done. But I think that if you go specifically to the Netherlands, they have slightly different. I think that's 1.8 meter, etc. You can definitely look at mitigation options and the effect of balustrades, of screens, of trees. Again, that comes down to resolution and precision in the simulation. The resolution of the mesh will have an effect on how accurate your actual results will be, right? So if you go very coarse, it might often actually, what I've seen is often it looks windier, and when you go more fine of a resolution, but therefore also more time consuming and more costly, the comfort values actually go down, but don't pin me on that, right? But that's what I've seen so far. But with those higher resolution simulations, you will also see a better difference between if you do stick in a balcony, a balustrade, or a parapet, or some trees, because specifically the trees. So the trees are porous volumes, right? And basically what that does is the wind still flows through these cells, but it kind of absorbs the energy of the wind velocity, so it slows down the wind you do need a number of cells to look at that physical effect, let's say. But again, that's actually the whole SimScale and the Pacefish solver that takes care of that for you. You don't really have to go into detail of how to set that up, which is quite convenient.
Sure. Okay. We have two more questions. I'll give them at the same time. Ricard, the first one's for you on weather data. So an attendee is asking, what is the source of the weather data, and can a user add custom weather data? And Jerome, the second question related to your point a little bit is, what if you have an architect who wants to use this at the early stage design, really isn't an expert in microclimate analysis or CFD, but can follow the instructions, click the right buttons, get some outputs. What kind of sense checks would you recommend in there for someone to get started using this tool? So Ricard on the weather data, and Jerome on, I guess, the managing the process, embedding this in early stage design, first time users.
So for the weather data and the app, we have a manual option to upload and import your weather data. There are multiple free sources available that have standard weather files available that are compatible with the app. That's a stat file that you typically get from energy simulations as well. We can also refer to some, and we do in our documentation as well. On SimScale itself, if you also have a SimScale license, you can also get access to MeteorBlue integration. So we have a MeteorBlue connection that directly imports data for any location of the world from the MeteorBlue data set, which is not yet available in the app.
No, but we'll put that soon in the app, actually. That's one of the high priority items for the next version. That's why already you actually put the location in. So we've been thinking about that. It's just not wired up yet. Yeah, that's a good question, actually. So there is, well, first of all, there's a lot of theoretical papers and stuff around, but we don't want to bore people with that too much yet. Although a lot of that is actually embedded within the app in a way, right? So there is rules of thumb, actually not rules of thumb. There's actually, it's a bit more precise than that, let's say. How large your wind tunnel should be. So it's dependent on the tallest building in your domain. So it should be 5 to 6 times the height, the length, the width, all that sort of things. How much you should model. We got some information on our documentation. So actually, the default documentation from SimScale is really good in that respect. We're working on the app itself, on the documentation, and actually kind of cross-linking that up. So I think there is stuff out there. Hopefully, it's fairly intuitive, the app, but please do let us know if you give it a try, if it is that intuitive or not, right? Like, that's the other thing as well. Like the app is brand new, so we're also still kind of figuring out and listening to feedback. And then, I mean, there's always the high resolution simulations where, like if you, for instance, here in the UK, it's a direct planning requirement to look at pedestrian wind comfort, right, for a tall building. That's probably where, that's a bit later in the stage, but that's where you want to have the high resolution. So you do know that the tunnel is high enough, your precision is fine enough, and all that sort of things. Don't know if that answers the question a bit. I know it's a bit vague what I'm putting out there, but
it's good guidance. I think the trick is to get kind of started with this, right?
I think so, and
yeah,
that's what we're trying here, right? I mean, it's of course the whole CFD in itself, but also the comfort. It is a technical topic, but we're trying with the app actually to kind of break that entry, that threshold even further, and bring it even closer to architects and engineers to intuitively use it. Yeah.
Fantastic. We have some attendees just commenting on your presentation earlier, Jerome, when you mentioned about the Westminster model, the fact that you hardly spend any time or almost no time cleaning up that quite a large, complex model, right? Which otherwise might have taken you days to, redraw the whole model from scratch. So this plus the fact the advantages of the LBM solver, it is so robust when it comes to handling geometry, is one of the one of the biggest advantages of this approach, right? So it's great to see that attendees are kind of picking up on that point. And like Jerome said, you need to get started with this and see what a big difference it makes to your modeling workflows. Ricard, we did promise a couple of questions on the pricing. So we have a couple of people, I think the academic users, asking what the how they might access this for research, for teaching. Is that something you have any insights on?
Yeah, so for the app itself, there's no specific academic pricing model. We have on SimScale itself academic pricing models as well for pedestrian comfort and the Lattice Boltzmann solver. So you can reach out to us and ask for academic pricing, and we can tell you that. It's a small fee per user to basically cover our costs that we have for data storage and so on Amazon, but that's about it.
Fantastic. Okay, brilliant. I think we'll wrap up the Q&A session there. Thank you for all the attendees. We will, the link earlier that Ricard showed on simscale.com product integrations, where you can access the Nuada app, we'll send that around in the follow-up email as well, and a recording of this webinar. I also did post it in the chat in GoToWebinar. Okay, so thank you to everyone for their questions. I'm going to hand back to Ricard now to show you what's next and to close the webinar. Ricard.
Okay. Thank you, Nagman. Yeah, just one closing remark here is what's the next stage that we're thinking about and what's coming. So what we're doing here is to bring something that is actually really complex, required in the past, like an engineering degree and a lot of experience to run these studies in a meaningful way, plus a lot of manual labor, cleaning up CAD and meshing to a new level. And we want to do this one more time, and that is by actually integrating machine learning into the same process. So what we can do, we have, since more than 10 years, SimScale has now run CFD simulations in the cloud, and we have gotten a lot of experience and actual data, data from thousands, hundreds of thousands of simulations that users generated. What we can now do is enable AI-enhanced workflows that make use of all this learning. So October 1st, we'll have another webinar where we will introduce AI Solve on SimScale, which is a data-driven machine learning approach where within seconds you can solve problems on a rough level, So machine learning will not give you to the last percentage the accurate result, but it's another order of magnitude faster, at least, or even more than already the very fast CFD solvers that we have in SimScale. It enables you to have a much broader view again on your problem space and the solution options that you have, and quickly check different design options and get an idea before you actually decide to run a full resolved simulation on the designs that look the most promising. So yeah, I invite everyone to go to simscale.com/webinars and sign up. I think it will be interesting to see what's coming soon to SimScale. Okay, and with that, thanks everyone. Thank you, Jerome, for taking part in today's webinar. Thanks for all attendees. And if you have any questions, drop us a line, and we try to explain everything in detail. And I would like to get any feedback you have while using the app so we can learn and improve it further. Thank you.
Absolutely. Thank you.